I apologize. How many folks want to come see me, not on this stage, but on the entire stage? Throw your hands up. I apologize. I'm here now. I hope that you will stick around and get some food and drinks later. Apologize that we had a snafu earlier today. Excited to be here and still give this talk. And just wanted to quickly ask, how many people here use JavaScript? Raise your hands. Great. How many people run NPM? How many people use Yarn? Okay, cool. It's some overlap here. So today, I'm going to be talking about securing your software supply chain. Specifically, I'm going to be doing it through the lens of the JavaScript ecosystem and as a package manager, also sort of sharing the insights and knowledge that I have, and also talking a little bit about the future of what we're doing within package management and also with the NPM registry, some really cool innovations we're doing there. So if you don't know who I am, there's a little bit of information here about me. I am a staff software engineering manager at Github, and I manage the open source NPM CLI team as well as the GitHub CLI team. We actually support quite a big portfolio of projects. If you want to follow me on Twitter, it's just at Darcy, my first name. And I come from Toronto, so I'm really happy to be here. The event organizers have been great, and this conference has been amazing, so thank you for having me. So if you don't know anything about NPM, right, sounds like a lot of you do know some things, which is great. But NPM essentially lets you develop, run, distribute, and discover packages. And of course, the thing that we're here today to talk about is that last bit, which is how do we secure your packages and how do we make sure that you have a safe experience while downloading dependencies. My team specifically actually supports roughly 100 open source projects, which account for about 2% of registry traffic that we see. So about 3 billion installs a month for our software. So this talk and security is very important to me, my team, and obviously to the JavaScript ecosystem. So why are we here? Why is this important? Well, supply chain security and security in general is critical to the long-term success of open source. Without this, I do not think that open source can succeed long-term. Corporations have bought in, and hopefully open source has won, at least in the short term. But without security, without some hardening of our best practices, open source is sort of at risk of not being successful long-term without this. So to give you some stats, give you some information about what's happening today, it's about a 650% year-over-year increase that we're seeing people try to actually attack the open source supply chain. So there's active actors out there that are actually trying to disrupt and get credentials and try to steal money from you and your end users. And so this is a huge, huge increase that we're seeing year over year. This was done by Sonotype. There was a research paper that they did that found this out. We're also seeing a lot of news about crypto miners trying to exploit the NPM package registry. There's reports and companies that are coming out all the time about the state of security within the package ecosystem. And actually Socket, which is a fairly new company, I know Ferris might be in the audience here, also did a talk at this conference, has started to do some sort of metadata analysis and applying heuristics as well. So there's a lot of work going into this ecosystem and into security. And there's obviously a lot happening and a lot of news about what is actually being exposed within the package registry. So what is it that people are trying to exploit, and what are we trying to protect when we talk about supply chain security? Well, we're trying to protect trust. So actors essentially use your inherent trust of packages and dependencies to try to slip in malware and exploit vulnerabilities within packages. So this is the thing we're trying to protect. It is the thing that will make us successful long term, and I hope that in 10, 15, 20 years, we can say that open source is still trustful and it's secure. Within the JavaScript ecosystem, you obviously trust a whole bunch of software, engines, runtimes, package managers like NPM, and a whole bunch of other frameworks, tools, build tools, and dependencies. Today I'm specifically talking to those last pieces, the dependencies that are actually within your projects. So package managers, languages and tooling, transpilers, all those types of dependencies are the things that I am very concerned about as a package manager maintainer. To give you some sense of the scope of this problem, especially within JavaScript, because we are so successful at giving away software for free. The NPM registry houses over 2 million packages. So thank you very much for contributing. There's a lot of software available for people to download and execute that lives on the NPM registry. And we see over 190 billion, with a B, billion downloads a month. And we continue to see that exponential increase of downloads and installation. So if you're a JavaScript developer, you're in this room today, you are successful, and hopefully will have a long career in JavaScript. So very happy that things are looking good in that regard. So how are we actually going to secure the supply chain, and what is the critical piece that we need to focus on? And it really is the dependencies that you trust. And for me, this is the pivotal moment and why I spend so much time staying up late thinking about how do we secure your dependencies. Because there's a lot of them. A recent study actually showed in the state of the Octoverse, so this was a study by GitHub, that JavaScript projects actually have roughly almost 700, 683 transitive dependencies. And we talked about transitive, we talked about not directly, not a direct dependency of your project. So something that was installed because a direct dependency of yours might have it as sort of a third-party dependency. So you did not actually say that you wanted this thing, but it's coming along because your other software requires it. So this is crazy, a crazy big number, especially when you compare it against other ecosystems. The PHP groups, the Python groups, those projects do not have the same kind of scale and the same kind of problem. And so really, the JavaScript ecosystem is the one that really needs to care about supply chain security, and is definitely the one that can actually fix it. So of sort of the vulnerabilities that we see specifically within the JavaScript ecosystem, we see roughly 75% of those vulnerabilities living in the transitive dependencies. So this thing that you didn't even require and you didn't even say you wanted is coming along for the ride, getting installed on your machines, in the cloud, in your production environments, and it potentially has vulnerabilities or has malware. And we ourselves at GitHub host a whole bunch of advisories about potentially vulnerable software. We have roughly 2,600 advisories for NPM, and we've actually just recently, in the last year, started to publish malware takedowns. And so in the last year, we've published 7,000 malware takedowns. So we are actively working on removing bad software from the NPM registry. And of course, as you would expect, the majority of the CVEs that we host on GitHub are for the NPM ecosystem. Of course, if we break this down even further, what do those advisories look like? Well, 17% of them are actually for malicious software. So it's intentionally trying to do something like exfiltrate data, steal secrets, call home. But the vast majority of the advisories that we have within the GitHub Advisory DB are actually for mistakes, or what we call just vulnerabilities. Somebody who is a good intentioned developer just happened to create some software that's insecure, is now potentially being relied upon by a number of people, and potentially could be exploited by bad actors. So there's actually probably one of the scariest stats that I have today is how often is this going to become a problem for you as a JavaScript developer? And we see that roughly 59%, there's a 59% chance that you are going to get pinged about an advisory or be given a security alert within the next year. So you're going to get annoyed that there's some sort of problem with your dependencies or some sort of issue, and we're going to tell you about it. And we have almost 60% chance that we know that we're actually going to do that within the next year. So if we break down some of the actual threats or the threat models that we have available to us to look at how these things break down, the Salsa working group and specifically the OpenSSF have put together a really good model here. So I've taken that from them. And when we look at these different potential sort of attack vectors or potential issues with the supply chain, we're mostly focused on, within package management at least, the E, G, and H sort of threats, which are a compromised dependency is getting used, or it's is referencing a compromised repository, or we actually are serving somehow malicious software to the end user. And so we really care about that last mile in which a consumer actually gets the software and then executes it. So when we talk about those threats, there's a whole bunch of them here. Malware, of course, is the worst, but there's things like typo squatting, dependency confusion, registry compromise. So we want to make sure that you know that the software that's hosted within the NPM registry is safe and has not been tampered with. And then, of course, the one that we are really, really concerned about is account takeover. So when somebody is able to steal your credentials, impersonate you, and publish software as if they were you. So how can we actually mitigate these? Mitigating malware starts with actually doing some scanning. And the companies I showed before, a lot of them are actually helping to do that malware scanning. They're monitoring the NPM registry. They're doing some malware detection and actually submitting those CVEs or essentially takedown notices for us to actually remove malware from the NPM registry. We've also done a lot of work within GitHub and NPM to improve our actually tooling and automation. So the support teams that are actually behind taking down this software have really drastically increased their response times. And of course, we are publishing the advisories when we do take down malware. So you are aware that you potentially have gotten something on your system that you don't want to be using. Typo squatting, how do we prevent that? There's some good heuristics around this. You might have noticed if you tried to create a new package that's called like React E with like a E on it, or React Y, like just a single character difference to a popular package. We use heuristics and policies to actually enforce the fact that you can't, name a package so similarly to existing popular packages. And so using policies and enforcement around this, we can help try to mitigate typo squatting. Dependency confusion became really popular. This is also sometimes called substitution attacks. We ask that folks try to avoid proxying as much as possible, but if you're working within a large organization, you're probably using a proxy to host private packages, which is understandable. And if you're doing that, please use scopes. That's the privileged way of saying you want to own some piece of the NPM registry you should apply for and own the scope that you're actually using within those private registries that are proxying through. And we actually wrote a whole blog post about this back in 2021 that you can go check out, which gives you some more information about how to avoid dependency confusion or substitution attacks. Of course, registry compromise is very concerning. If somebody was able to access, the my auth credentials, or somebody on our teams and was able to get access to the NPM registry, change some software on the registry and be able to distribute it, would be a huge issue. And so what we actually do on sort of the front end is we store things like lock files. I'm sure you've heard of. We do package signing on the registry, and we actually have recently evolved and made modern our public key signing. And actually just recently in this past summer went through a whole exercise of re-signing every package on the registry, and have some new tooling that I'll show in a second here. Account takeovers, again, are very policy driven. The way to mitigate account takeovers are through things like increased identity verification and validation, things like 2FA. We are starting to enforce this for really high impact projects. As of November of this year, we'll actually be really enforcing this for those high impact projects, which equate to a project that has over 1 million downloads or over 500 dependents. So the thing that I didn't put down as a threat to the supply chain and to the JavaScript ecosystem, but I want to focus on now, and I think is really important, and is this getting, oh, looks good, is mutability. And I'm not sure how many people know this is a problem, but mutability within package installation and in the JavaScript ecosystem is a huge problem, especially with things like lifecycle scripts and remote third-party dependencies. So when we talk about mutability, what are some of the ways in which it creeps in? As I said, remote references, or package specs as we call them, are a huge problem here. So distribution tags that you reference can be changed and are mutable reference to a package, as well as actually remote tarball URLs and Git repositories. So you may have a dependency within your stack today that actually has either direct or a transitive dependency that is actually living on a third-party host. And you don't even know that you just installed software from my own personal website or somebody else's personal website, or a place that isn't really a trusted host. And so we're trying to work on sharing and sort of elevating this sort of problem through giving users more information, and I'll show what that looks like here in a second. We also ask that folks use lock files as much as possible. Hopefully, everybody here is. Anybody not using a lock file? OK, there might be reasons you're doing that. Maybe you're a maintainer of a project. You might use shrink wrap files instead. But the really important thing with lock files is that they store critical information so that we can do our best job at reproducing or creating reproducible installations. And so things like integrity values, which essentially hash the package, get stored in lock files, the tree shape and sort of the resolved references. So we look at validation and validation of things like lock files. NPM specifically does validate the package signatures that are returned from the NPM registry. But we also do integrity value validation from lock files. The things we don't validate, which cause also immutability to exist, are those resolved references and the actual tree shape that exists within the lock file. So there's no easy way to essentially do that validation. And actually what this means is that somebody can manually update a lock file, introduce a extraneous dep, and it'll actually get installed. So that's a problem that exists today, something that's known, and obviously something we want to do something about. So there is this really interesting thing that you've probably never heard of. You can actually do some time travel with the before tag. So any package that is on the NPM registry that has timestamps associated with it, you'd actually use the before flag, give it a timestamp, and we will actually download a subset of the manifest information to give you the version available, or all the versions that were available at that point in time. So this is a bit of a security feature that could be a security feature if all of your dependencies were immutable references to the registry and not third-party remote dependencies. So there's this great quote that says, "No man ever steps in the same river twice." If we were to modernize that to modern day, it might say something like, "No package JSON ever installed the same way twice." This is very true with the mutable references that we have in our projects today. It's a scary situation to be in, and we hope to move into an immutable direction long term. Of course, the only way to actually prevent all this is if you're a robot and you're caching and bundling all your dependencies, but I totally understand that is not feasible for most folks. Of course, you're now looking at me like, Darcy, this is a scary talk. It's at the end of a conference. You were supposed to be giving a talk a little while ago on the main stage. I'm now, a couple drinks in or a couple coffees in. My anxiety is super high. What can we do about this? Because it sounds like my node modules are super opaque. It sounds like I don't even know what I'm going to be getting. It sounds like there's way too many node modules and packages in my projects. And holy cow, this is all really confusing, or like aliens. So you just want to go back. I'm sure you want to go back to a time when you didn't know any of this information. And I apologize. That's just not the case. But I do want to talk about, hope. I do want to talk about the future, and I do want to share with you some really cool things that we're working on to hopefully resolve a lot of these problems. A big one is reproducible installs. And so reproducible installations can only come when we have more immutability in your projects and within your dependencies. So RFC that I put together last year, and also Yarn has been looking at something called variants. We are going to be hopefully working together here in the near future, on this concept of package distributions. And package distributions is the idea that you can essentially create a manifest that lets you know you can swap this package for a version of it that might be specific to a specific platform. This is to try to mitigate the need for post-install scripts, which often are used to download native binaries for the system or platform specific that you need, and really go back to sort of first principles, asking people to use packages as the source of truth and as the artifact, the final artifact that you distribute. So this is an RFC, a proposal that we have open right now. We're going to be working on this in the next year. We're also making audit improvements. This is very important to me specifically. Back in npm v 8.16, we launched something called npm query, and it supports this new thing called the dependency selector syntax. This steals from CSS some really cool syntax, which I'll show you here in a second, and really is going to bubble up metadata for end users and authors of JavaScript everywhere. We have really cool selectors, just like CSS. So here's a whole bunch of examples of how you can write a dependency selector. So this might seem very familiar if you've ever written some CSS in your life. And what we've done is essentially we parse these selectors and transform them to apply to the dependency graph, making it really easy for you to ask questions and get back answers about your dependencies, hopefully educating people and making you that much more aware about what's happening inside your node modules. Some really cool examples of what you can do with these CSS selectors is create robust questions and selectors, like finding all the specific licenses or packages with specific licenses, finding specific dependencies with engines, fields, using arbitrary query selection. And also there at the end, the very last example here is finding all those packages that actually define install scripts and saying, hey, wait a second, I have a lot of dependencies here that actually are trying to do something during installation. And so we think this is very impactful, and it's going to be essentially core to all the future functionality we build into NPM. And you can actually consume this and work with this programmatically. We have this package called the npm CLI Arborist package. It's essentially the brain of the npm CLI, and you can consume it in your projects and build tooling around this. And the really nice thing is, again, if you're a front-end JavaScript developer, this might look very familiar to you. There's a query selector all function on our tree class, which is really cool. And you can pass it one of those selectors and basically walk your dependencies and get back your filtered set of those dependencies to do some really cool things with your programs. So if you're using the CLI command, it's just query, npm query, again, available as of 8.16. You can do some interesting things like pipe that JSON output to JQ, get back the version and name of things. And there's some new selectors that we're actually working on right now, and they're coming down the pipeline. Improvements to the Sember pseudo selector that we introduced, so you can actually pass it a specific value or version within a package manifest, and you can query based on that. Things like outdated and other sort of registry or remote manifest information, including audit information, is going to be queryable soon. And this really helps you, dig into vulnerable versions of software and query by it or filter by it, which is really cool. So again, something that we're looking at in the future here are sort of audit filters. So people have told us that audit is way too noisy. Some very prominent people have told us that it's way too noisy. And so we can use that query selector syntax to essentially apply filters or to apply queries to npm audit. So you just get back the important packages that you care about to actually be ensuring that they're safe. Some validation enhancements, and I know I'm going to be running a couple seconds or a couple minutes here long. I apologize. We made a new command called npm audit signatures, which actually does that validation of your package's signatures. And we launched this, I believe, back in 8.13. So if you're on that, you have this available to you now. And this does a validation of those registry signatures I was talking about earlier. And we're actually looking at right now some proof of concepts around using SigStore as also a signatory ledger that we can reference and use within the npm CLI. Just one last item that we're looking at is audit policies. And this spec and this sort of drafted RFC outlines something that looks very ESLint-like, where you can define essentially a name, type, and query of a policy that you want to enforce on installation. And you can do something like log, warn, or error if that matches any dependencies. So this can be the gate that you use to protect yourself against heuristics that we don't even know about. So if your company has specific issues with licenses you use, you can make a query for that license, ensure that you don't actually install the dependencies that have that license, and use it as these policies essentially as gates around ensuring that you're keeping up to your own best practices. So key takeaways here that if you didn't listen to me at all in the last 25, 30 minutes, supply chain security is a team sport. I hope everybody here feels like they can actually do something about this. They're interested, obviously, in how they can secure their projects long term. There's not one solution that's going to solve this problem. There's many different types of features that we need to offer to the community to actually improve the situation. And I hope you're excited and hopeful as we look forward. There's one last resource I wanted to share, which is the OpenSSF has put together a whole list of best practices for package managers, specifically NPM, and you can go check that out. It has some of the things that I've detailed in my slides here, but also a whole bunch more, and it is a really good resource if you're looking for something to sort of check some boxes. And with that, I think I'm done. I appreciate your time. I apologize. I stole up all your snack time, but I want to say thank you, and I hopefully talk to you